Okay, so here we are. We're going to determine if the conditional statement is true or false. So if a figure is a triangle, then it is a right triangle. Well, let's see. If a triangle, then a right triangle. So I kind of draw that Venn diagram. I think we can all read this and say, oh, that's false. But I want to show you a visual. We've got the triangle and then we've got the right triangle. Well, not all triangles are right triangles. We've got isosceles triangles. We've got scaling triangles. We have acute triangles, obtuse triangles that aren't right triangles. We can have an isosceles right triangle, but just because it's isosceles doesn't make it a right triangle either. So no, not all triangles are right triangles. So this right here would be considered false. Now the next one's a little bit harder. So determine if the following statement is true or false. If 2x plus 3 equals 7, then x equals 1. So this is where that Venn diagram might come in helpful. So what do we put in the smaller circle that's completely enclosed by the larger circle? Well, that's our if. If 2x plus 3 equals 7, then x equals 1. And that, I would say, is completely true. Every time you have 2x plus 3 equals 7, you're going to get x equals 1, but it's not the only way to get x equals 1. So there's going to be lots of other circles. For instance, x plus 3 equals 4. That's another way that x could equal 1. So 3x equals 3. There you go. X equals 1. Lots of different ways that you could get to x equals 1, but if 2x plus 3 equals 7, then yes, x has to equal 1. Now, the converse, we've already talked about a converse, so I'm not going to use a color right here. The converse interchanges. It interchanges, and you can probably already write this out, the hypothesis and conclusion. So if my conditional statement is if P, then Q, the converse is going to be if Q, then P. And we know that when the conditional statement is true and the converse is true, we can write a biconditional statement. The inverse negates the hypothesis and the conclusion. So it negates the hypothesis and the conclusion. So the conditional would be if P, then Q. And actually, you know what I'm going to do? I'm going to color code all of these. Let's make this dark blue. No, let's make a different color. So let's make this, let's make it orange. And I'm going to make this orange. And then the conditional is going to be black. And then here I'm going to make that conditional the same thing, black. Because this might get, you might have to go back to it and go, okay, what, all these P's and Q's. So the conditional is always going to be if P, then Q. And the inverse is going to negate the hypothesis and negate the conclusion. So we end up with if not P, then not Q. The contrapositive does both. It flips the hypothesis and conclusion and negates it. So flips and negates. Flips and negates the hypothesis and conclusion. So again, if we have if P, then Q, the contrapositive is going to be if not Q. See, I'm going to take the negation and flip it at the same time. If not Q, then not P. So let's try this with some real hypotheses and conclusions. If you are 15, then you are a teenager. So if you are 15, then you are a teenager. If you are 15, then you are a teenager. The converse is going to flip. So I'm just going to highlight so I can see my hypothesis and my conclusion. And when I flip, the converse is going to be, if you are a teenager, then you are 15. Now I think that we can all agree that the original conditional statement is true. And I hope that we all agree that the converse, if you are a teenager, then you are 15, is most definitely false. Now the inverse is going to negate the hypothesis and negate the conclusion. So if you are not 15, then you are not a teenager. Well, we know that's not true either, because if you're not 15, you could be 14 or 13 or 17 or 16 or 18 or 19, and those are all teenagers as well. So that's definitely false. And then our last contrapositive, if you are not a teenager, if you are not a teenager, then you are not 15. Well, that's most certainly true. If you're not a teenager, then you're not 15. Because if you're 15, you have to be a teenager. And holy cow, right there, if you're 15, then you're a teenager. So these two being true, both true, I wonder if that happens every time. I wonder what happens there. So let's see. Let's do a try. And let's see if we can figure out what the relationships are. So write the converse, inverse, and contrapositive of the conditional statement and state the truth value of each. You go ahead and press pause, and when you're ready to reveal the answer, go ahead and press play. Okay, so if tomorrow is Thursday, then today is Wednesday. Well, the original is true, and the converse is true. The inverse, if today is not Wednesday, then tomorrow is not Thursday. Well, that would be true as well. And our contrapositive, if tomorrow is not Thursday, then today is not Wednesday. And that is true. It's most definitely true. If tomorrow's not Thursday, today's not Wednesday. Well, look at that. These two shared the same truth value again. And what else? Well, look at that. These two shared the same truth value this time. Did they share the same truth value on the last one? Let's see. They sure did. They were both false. So that actually is something that will always happen. The conditional statement and its contrapositive will always share the same truth value. And the converse and the inverse, I believe those do the same as well. But when you're doing your assignment, you're going to be able to find that out for sure. and confirm what I'm going to write down here below. Okay, this right here is a little bit of a try for you. Mr. Perkins heard an advertisement that said, if you take a multivitamin tablet each day, then you'll stay healthy. Mr. Perkins began to feel uneasy, thinking, if I don't take a multivitamin tablet each day, then I won't stay healthy. Is his thinking valid? If so, explain why, and if not, explain the error that he is making. So I have a really great explanation for this that is, let me see how many words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. This is almost like an essay. 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61. Aren't you glad that we're doing this on video? Because I have an explanation from a student who did this in class one year, and it was 61 words. That was the student's explanation. It was 61 words, and I can give you a quick snapshot of it. Not gonna go there for too long because I don't want you to see. Oh gosh, if I go there too long, you can pause the video. But there you go. Did you see that? Did you see that? There you go. It's a little bit of a blur. It's that right there. So see, you almost had me. I'm in the classroom. I got it, you know, I know what to look for, but in the video, I'm learning. 61 words is what someone came up with, so see what you can come up with. And in another assignment this week, I'm going to ask you for your answer. So just be prepared to give that answer later on in the week. Meanwhile, did you figure out which ones always share the same truth value? Because I'm going to write it right down here. It is the conditional and the contrapositive. They call these two logically equivalent. Logically equivalent. That means that they share the same truth value. And the other two that are logically equivalent are the converse and the contrapositive. And then, of course, we know that when the conditional and the converse are both true, when conditional and converse are both true, you know what's coming. What's coming? Because we've been over this. We have a biconditional statement. And I know that you likely remember exactly what a biconditional statement is, but in case you've forgotten, it's that if and only if, the IFF, the if and only if. So I encourage you to go back to your notes and take a look at that and see if your memory recalls how to write a biconditional statement accurately. Thank you for listening, and tune in to some more video lessons.